Alright, this is the original design that we came up for our controller for how long a pump runs. The original design we had, powered by 9 volts, and this is the ladder logic for it. And we're just going to run through an original idea, or the original concept, because a lot of these ideas made it into the final design. So, the original way we had it set up is 9 volts supplied, and then we have a momentary, normally open start button. So, the schematic goes, when you press the start button in the front, it latches the relay, which sends power through the normally closed stop button into our pump, and the pump starts running. At the same time, in parallel with the pump, is the coils for another relay. We call that pump relay. So when you press the start button, the pump is energized and the coils for the first relay are energized. That relay in ladder logic is over here. So we're going to pretend that we press that button and all that's running now. So since this is momentary, this will open back up. And then now that the pump relay's coils are energized, this relay closes, which sends power. This is the ladder logic, so we jump down here. That powers our 555 timer, which powers the 555 relay and closes this and keeps the whole system running. Now this whole time the 555 timer is counting down time. And what the 555 timer does is when it reaches its time constant, it'll cut off, which will stop energy to the coils to our 555 relay, opening this and breaking power to the pump, shutting it off.
Okay, the problem with our first setup is that we weren't getting enough amperage to the 555 relay. So our next step was to try this setup. And what we did is take the output from the 555 timer and ran it to an N-type MOSFET transistor. From the transistor, we went to ground and to the pump, and then off of the pump we put a diode. The diode is to keep it from back charging once the circuit had ran, and then the pump had to be powered by a separate 9-volt battery.
Our timer is controlled by a 5-turn potentiometer. We measured the resistances at each one of the notches and found and calculated our time to be 1.5 seconds at the first notch, 6 seconds at the second notch, 11.9 at the third, 17 at the fourth, 23 at the fifth, and when we turned the 5-turn all the way up as far as it would go, we found that we had an additional few kiloohms of resistance, so we calculated it at being close to 24 seconds when turned all the way up. So our timer can stay open anywhere from 1.5 seconds to 24 seconds.
This is our original apparatus. It was designed to take 2 liquids into these containers and feed them through normally closed solenoid valves, and the solenoid valves would be controlled by a 555 timer to open up the normally closed solenoids. Now we were unable to secure the solenoid valves that we wanted to use, so we went with a pump design instead. Once we got our 555 timer circuit working, we attached it to the apparatus and we filled these containers with the liquid. However, we were unaware that the pumps did not have a stop valve on them, so due to the force of gravity, water just kept flowing through the pumps and kept coming out whether the circuit was activated or not. For that reason, we were unable to use this original apparatus.
Here is our 555 timer circuit, and this is our MOSFET. This is our potentiometer. It is set to pin 1 right now, and to run for 1.5 seconds. And the output of our 555 timer is right here at pin 3. It's running to the gate of our MOSFET. Our source for the MOSFET is going to the negative line into the motor, and our drain over here is going across and back to the common ground. We have our power here for the timer itself, and our power here for the pump, and yeah. It's all set up, it's ready to go. So let's run a test. Alright, everybody ready? Alright, 3, 2, 1, go. Okay, we've measured the volumetric flow rate to be about 4 liters per minute. So we've set the resistance to allow it to fill up 1 liter of this. It'll run for approximately 15 seconds. The resistance on that is approximately 62 kiloohms. So let's see how it goes. Yes. Okay, the potentiometer has been turned to the second slot, and this should run for approximately 6 seconds. Powering in 3, 2, 1.